Good afternoon all. I am Professor Suresh Charola, the Assistant Professor in Electronics and Communication Department, Marwadi University. Today I am going to discuss about the code conversion method, the different types of the code conversion method. We are going to directly the code conversion. First, let us discuss about why the code conversion is so important. Let us suppose consider the different electronics gadget or digital hardware. Out of that, just take an example of a computer. So it's a machine can only able to understand the two numbers only. Either it should be 1 or it should be 0. That means it can able to understand only the binary system. But suppose as a human being, if I had give the number of streams of ones and zeros, it is very much difficult to identify by the user that what number exactly is. So to make it so simple, we have a different number systems like binary, octal, hexadecimal, BCD number, XS3, Gray code, ASCII code, and etc. If I'll talk about the types of code conversion, we'll discuss in this lecture the binary to how to convert binary to gray code or gray code to the binary. There is another is decimal to BCD or BCD to decimal, and third conversion is binary to ASCII and ASCII to binary. Fourth, that is a BCD to EXA and EXA to BCD. Now you can see these are another applications of this code conversion method where it will be useful. Let's suppose take an example of an keyboard. If you are typing a character, a is cannot able to understand by the computer. What actually the computer will do, this ASCII character will be converted first into the hexadecimal, and then the hexadecimal is converted into the binary form. Then the machine can understand, okay, the number I got from the keyboard is nothing but a character A. So such code conversion is very much important, how the machine is converting from ASCII character to the binary character. Let's suppose take for an example first code conversion method, that's binary to gray. Let's suppose if you talk about this binary number system and the gray number system, if you look at the sequence of the binary, it's a 0 0 0 1 1 0 and 1. If you look at the gray sequence, it's 0 0 0 1 1 1 and 1 0. Let's suppose first take how to convert the binary number into the gray number. Let's suppose consider you have 5 bits of binary number. Let's suppose 1 1 1 0 1. Now I need to convert this number into the gray number. What is the G1, G2, G3, G4 and G5? The first bit, the B1, should be right as it is. Okay. Now next what you need to do, you have to do the XOR of a B1 number with a B2, and doing the 1 XOR 1 you will get output as a 0. Again same, if I do the XOR for binary B2 and B3, I will get the number 0. Same, if I have a binary B3 and B4 XOR, I will get output as a 1. Again 0 and 1 XOR, I will get output as a 1. Okay, so this is how we can able to convert from binary to gray number. If I want to implement this structure in forms of gate, like B1 is directly been given to the G1, so B1 is been directly given to the G1. Now for the B2, if I want the output as a G2, what I need to do, I have to do the XORing of B1 and B2. So it's a B1, B2 XOR, I will get G2. Same as a G3 and the G4. This is nothing but a gate level implementation from binary to gray. Let's suppose if I want to convert the gray number to the binary number, what I will do, let's suppose consider the same number for the gray number, like 1 0 0 1 1. And if I want to convert that gray number into the binary number, you have to write the G1 as same as B1. Now to convert if I want to find the B2, what I will do, what are the answer I got as B1, I will do the XORing with the G2, and what answer I will get, 1 XOR 0, I will get answer as a 1. Again same, I will do the XORing of 1 and G3, I will get output as a 1. Again 1 XOR 1, output is 0. 0 XOR 1, output is 1, such that we will get a B1, B2, B3, B4 and B5. Now if I want to implement the structure in the gate level, what I can write, directly the G1 has been given to the B1. Now what about the B2? I have XOR with B1, XOR with a G2, that is a output what I get. If I want B2, I have a B1 and G1 both are equal, so I will give first input as a B1, next input as a G2, then I will get a B2 as output. Let's suppose if I want to use as a B3, what it will be, it is nothing but XORing of B2 and G3. So it's a B2 and G3, I will get output as a B3. So it says same as a B4. Now let's suppose take one example 1. I have B1. This is a binary number. I need to convert into the gray. What is the first thing? As a B1 I should write as it is. I have to do the XORing of 1 and 0. What output I will get? I will get a 1. Same, I can have a number and 1 1 XOR 0. If I take another example, let's suppose binary number 0 1 1 0 0. What I will write? I have to convert the binary number into the gray number. What else 0 as it is? XOR 1 XOR 0 XOR 1 XOR 0. Now let us take the example how to convert any gray number into the binary. For example 1 1 1 0 0 I have to convert that number into the binary number. So first number G1 I should have put it as it is. Then I will do the XORing of B1 and G2. 1 1 XOR should be answer 0. 0 should be right over here. Again 0 1 XOR 1 0 XOR 1 1 0 XOR 1. So this is nothing but a binary number. How I will get from gray to binary. Now if I will take the example how to convert any decimal number into the BCD code. That means if I want to convert 4926, BCD is nothing but a binary coded decimal. Okay, like 0 to 9 I have a same as a binary input, but if I want to represent 10, what should I write? I should write 0001, and for 0 I will write 0000. Let's suppose consider that I have the decimal number 4926. I want to represent that number into the binary coded decimal. For the 4 I will write 4 bits, that is 0 1. It should BCD number to represent any number. It should be utilized only 4 bit. Like 4 I can write 0100, 9 1001, 2 0010, 6 0110. So what is the application of to convert the decimal number into the BCD number? Let's suppose if I want to have a decimal calculator over here. This is nothing but I have a decimal to BCD encoder IC which will convert the decimal number into the BCD number, and it will be able to display over here. Let's suppose if I will press 0, the BCD output will be 000. Now if I will press 5, output will be 010. If I will press 7, output will be 0111. If I will press 3, it will be 0011. That is, encoder are available in the form of IC. The encoder translates from decimal input to the BCD out. This is the one of the application of the BCD decimal to BCD. Now suppose if I have the BCD to decimal number, the vice versa. If I want to convert any BCD number into the decimal, let's suppose I have 1000, 0111, 0001. I want to convert this number into the decimal number. So 100, you know that it's 8, 0117, 0001, 1. So this is nothing but a decimal representation of a BCD number. Now same, if I want to use the application, you already studied about the 7 segment. The 7 segment is nothing but it will on when I have, let's suppose if I will give the BCD number 000, it will able to display 0 on a 7 segment. If I will have 001, it will display the 1. If I have 010, it will display the 2. Same if I have 0113, if I have 14. So the electronics decoder are available in the form of IC to convert any decimal number BCD number into the decimal number. Okay. Now what should be the decimal output of a decoder that appears on a 7 segment? If I give 0011, its answer is 3. Now what is the decimal output for the decoder that appears on a 7 segment display for the 0000? It is nothing but a 0. Now what is the display for this 1001? It's a 9. Now how to convert any binary number into the XS3 code? Okay, if I have for the 0 representation, binary can be represented as 000. For XS3 it represents as 000. If I have any number, okay, let's suppose take any number like 5. 5 can be represented as a 0 1 0 1. If I want to convert this binary number into the XS3 number, I will just add 3 to this number 0 0 1 1. Now if I do the total 1 1, sum is 0, carry is 1. If I again add 1 and 1, sum is 0, carry is 1. 1 plus 1, sum is 0, carry is 1. Again 1 plus 0 1, 1 plus 0 again 1. So it's nothing but a 8. So 5 plus 3, answer is 8. So I can able to convert any binary number into the XS3 number just by adding 3 to that number. Okay, sample problem if I'll take the decimal number 359. If I want to convert this decimal number into the XS3 code, what I will do, first I will add 3 number to 3, the binary, that is nothing but a 3 plus 3, that is a 6, 5 plus 3, that is 8, 9 plus 3, that will be a 12. Okay, understood or not? So this is how we can able to convert the decimal to the any decimal number into the XS3 number. Suppose if I want to convert binary to ASCII number, the full form of ASCII is nothing but a American Standard Code for Information and Interchange. If I want to represent, see, like keyboard, take an example of a keyboard. If I am typing the character A, the processor or a CPU cannot, a machine cannot able to understand what do you mean by the character A. So the machine will convert this character A into the binary number. Now how it is possible? There are in the keyboard, if you will consider with the symbol question mark, underscore, comma, double quote, a character, small character, capital, or a small letter, numeric number. If I'll combine this all, there are nothing but total 256 symbols are there. Now how to convert this character or a symbolic representation into the hexadecimal? Then you can directly convert from the hexadecimal to the binary. Let's suppose this is nothing but ASCII code I have. Now at the upper side, if you look what I have a number from 0 to 7. If you look at on the left hand side, I have from 0 to 7. Okay, so represent from 0 to 7 I required only 3 bits. To represent from 0 to F I required 4 bits. Okay, let's suppose first example, if you take the character K. Now where the character K at the chart, the character K in the chart. This is never your keyboard only. So it's the character K. Now you press the character K keyboard. What the first it will go in the row. The row is nothing but a 4 number. So first you will write a 100, that is a binary representation of 4. Where the K, the column is nothing but a representing on a B. So I can write 1001 for a B representation. Okay, so what is the value of K character, that ASCII character to the binary? That is a 1001. Now let us take another example. I told you same. If I want to represent as S, what I will do? S is nothing but over here. Now S is nothing but a 5. It requires only 3 bits. That is a 101. If I write 3 over here, it's nothing but a simple 0011. So binary representation is 1010011. This is how we can able to convert any ASCII number into the binary number. So if you have any questions, you can mail me on my mail ID, shreyas.charola@marwadeducation.edu.in. Thank you. Have a nice day.